This is Euclid Book 11, definition number 26. I'm going to go ahead and read this to you, and afterwards I'm actually going to draw it out according to Euclid's methods. And I want you to bear with me because it's a tough drawing. Now remember, I know you can't see me, but that's not the important point. The important point is whether you learn anything from me or not. Okay, so seeing me is not important. Alright, Euclid Book 11, proposition number 26. It says an octahedron is a solid figure contained by 8 equal and equilateral triangles. Okay? Now, how do you draw this thing? Oh boy. This is not going to be easy. Okay? Now then, what we want to do is I'm going to draw a line like this. I'll go ahead and use my blue marker here. What we're going to do is we're just going to start drawing a straight line. Now what Euclid wants you to do is draw an entire sphere. We're not going to do that, okay? You can if you want, but it'll just be a lot easier if we skip that part of it. But anyway, let's just draw a straight line. What he wants you to do is he wants you to bisect a sphere. We're not going to bisect a sphere in this video. Okay? So what we're going to do is we're going to draw this line like this. And then we're going to draw a perpendicular line. I'm just going to draw it like this. Now the idea, I'm just going to put this up like this. Oh, we have to bisect this. So it'll be about. We're going to bisect this. And draw a perpendicular and bisect. And don't be too hasty drawing this. It'll look butt ugly. But anyway, the goal here, at least our goal will be I'm going to draw this about like thus. So now I'm going to label these lines here, and I'm going to go ahead and erase this from here on up. Okay. Now, the real goal of all this, and you'll have to bear with me a little bit because this is kind of complicated. Doesn't sound too complicated at first, but the reason why they want you to draw a sphere, now I hope I can do this. Man, this is going to be tough. Well, basically, you're going to use your compass, and I don't think this is going to work. I'm going to simulate this the best I can, but you're supposed to use your compass. This compass is just a little too big to use. But anyway, it roughly goes kind of like this. You're supposed to draw a semicircle like thus. And this line right here is going to be 3.5 inches. Now what you're supposed to do is you're supposed to take this length of 3.5 inches, and I'm going to express this the way he has it in the book here. We have A, we have C, this is point A, this is point C, this is point B, and this is point D. Now the objective here is you're supposed to take this line right across here, this DB right here, and you're supposed to make a square out of it. Okay? So that's what we're going to do here. We're going to make a square, and each one of the sides is going to be 3.5 inches long. Now, by no means is this particular illustration going to be perfect. I'm sorry, it's just not. We're doing the best we can here. If you'll refer back to my earlier videos in Euclid, I show you how to draw perpendicular lines according to what Euclid wants you to do. Okay, so that's why I say this is not going to actually be perfect. We'll get as perfect as we possibly can for this particular video. Now, as you can see here, we have a square here, and all four sides are going to be 3.5 inches long. Now, you can do this any way you want, okay, but it's supposed to be a square. Now, the square is going to be E. That's point E. This is going to be point F. This is going to be point G. And this is going to be point H. Now, later on in Euclid's Elements, they're going to show you how to draw a perpendicular line from a plane, just like you draw a perpendicular line from a line. We haven't got that far yet, but we're going to get there, so bear with me. Alright, now what we're going to do is we're going to draw two diagonal lines. It looks like we're going to have two 5-inch lines, or approximately 5 inches. And when we do, we're going to form a new point called K. This is going to be point K. Now, our next objective is to draw a perpendicular line from this plane. You see, this square actually makes a plane. And we're going to draw a perpendicular line from it. Alright? Now, the perpendicular line is going to be the same length as EK. Okay? So, basically, what we're going to do is we're going to draw a line. Since EG was 5 inches, we're going to draw a line from point K outward, perpendicular, 2.5 inches. Just like that. Okay? Now the next thing we're going to do is we're going to connect this new point, which by the way is point M. We're going to connect points F and M, and we're going to connect points M and G. Let's connect them. Alright. Looks like we're going to make nice and neat 2-inch lines. Or at least that's going to be a 2-inch line. I can't guarantee this one will be. Okay. Let's turn this around. Let's make sure you can still see this. We still, okay, let's angle this back a little bit like that. Okay, so we actually need to push it a little bit further like that. Nope, we need to bring it back this way. Now can you see it? Yes, you can see it now. Good. Now I'll push this up just a little bit further. Guess I'll push up just a little bit more. Can you see it now? Ah, yes, that's much better. As you can see here, we have your A, your D, your B, your C. Okay. We already established that these lines are going to be 3.5 inches long. Okay. And now, what we're going to do is we're going to draw a line from point K. It's going to be perpendicular to this flat surface here. Okay. From this plane. The plane EHFK, not EHGF. Okay, we're going to draw a line that's perpendicular to that plane. It's going to be 2.5 inches long. Just like this. Now remember, everything's going to be approximate here. You can do this with all your little tools, and I'm sure you're going to try, and you'll probably get this to work a little better than what I'm going to get it to do. Okay. Now we're going to connect E and H like this. Well, I'm sorry. We have a new point up here. The new point is going to be L. This is point L. So, we've already connected K and L together. Now what we're going to do is we're going to connect H and L together. We're also going to connect L and E together. Okay. There you go. Now, there's a couple more lines we have to connect. And I'm going to use a different marker to do this. Golly, that little thing came off. Alright. Because it's getting kind of hard to see all this. So, the next lines we have to connect are E to M. Okay, so we're going to draw a line from point E to point M using our blue marker. Now again, this won't be precise. If you want precise, you can use a computer program. I don't care what you do. You can actually draw this out. Okay, all you have to have is a straight edge and a compass. And you don't even have to have all these measurements if you don't want them. Anyway, I'm going to go on here, because Euclid wouldn't have used these measurements. Okay. Now we're going to make another line from L to G. Okay. Now let me make sure I've got all these lines, okay? Alrighty. Okay. Now we've got to make yet another line, and it's got to connect point L and point F. Like this. Okay, we've got a point L to G, L to F, E to M, E to G, F to H, and we have to connect one more line. We have to connect from H to M. So we're going to draw another line from H to M. And I think by now you can see why I had to switch markers, because you couldn't have seen all this without all this. Just would have been no way. There you are. H to E, H to M, F to G, and boy. As you can see, this kind of gets complicated here. Anyway, after you connect all of these points, now that you're seeing everything is connected, we have to return to the definition of Euclid Book 11, definition number 26. We will do that right now. Now the definition says that an octahedron is a solid figure. Well, this is a solid figure here. It's contained by 8 equal and equilateral triangles. Okay. Well, later on we're actually going to draw this out as a proof. We're going to prove that this is an octahedron. But wow. Equal and equilateral triangles. Well, I may have to wait on the proof until we get to it later in Book 13. But this is actually right here an octahedron. This is an octahedron right here. We've drawn it. You've seen it. Well, let's see if we can find some of these equilateral triangles. Well, obviously, And I would say this. Don't think that's 2.5 there. Okay, this is a 3-inch line here, so that wouldn't be it. I was going to say that probably one of the equilateral triangles is this one right here, which is E, F, and K, but that doesn't seem to appear to be that way. I don't know. That's 2 inches, and I imagine that's about 2 inches there, but that's not going to be. Yeah. I may have to wait on the proof to show you this conclusively. But this is your octahedron here. I'll do some more research on this before I go and say which ones of these sides is equal and equilateral. And then we can move on from there. But that is your octahedron. That's how Euclid wants you to draw it. Okay. It's kind of complicated, but we'll get to it. Alright. When I do this next time, I'm going to draw an icosahedron. That's right. So the next one will be an icosahedron, and you will see how it's drawn. It's funky, but kind of cool too. Alright. This is Ted the Speed Learner signing off. I will tell you more in a future video, so I want you to stay tuned.